Chapter 4, Density. Index, density on page 3, uses of density on page 4, density formula on page 5, density of different substances on page 6, measuring density of solids on pages 7 to 9, measuring density of a liquid on page 10, measuring density of air on page 11, floating and sinking on page 12, worked examples on pages 13 to 14. Density is the amount of mass in a unit volume of a substance. It helps us understand how compact or heavy a material is for its size. For an everyday comparison, a block of lead feels much heavier than the same size block of wood because lead has a higher density. The SI unit is kilograms per cubic meter. A common lab unit is grams per cubic centimeter. The formula is ρ equals mass divided by volume. The conversion is 1 gram per cubic centimeter equals 1,000 kilograms per cubic meter. Here are some real-life uses: engineering, calculating how much a structure will weigh based on material volume and density. Shipping, predicting if objects will float in water. Science, identifying substances based on their known density. Hot air in balloons is less dense than cold air, which allows them to float. For example, lead has a density of 11 grams per cubic centimeter. That means 1 cubic centimeter of lead has a mass of 11 grams. The formula for density is ρ equals mass divided by volume. Using the formula triangle, you can cover the value you want to find. To find mass, the formula is mass equals ρ multiplied by volume. To find volume, the formula is volume equals mass divided by ρ. Density of different substances. Here are the densities of some common substances. For solids, in grams per cubic centimeter, aluminium 2.7, copper 8.9, iron 7.9, gold 19.3, glass 2.5, wood 0.80, ice 0.92 for liquids. In grams per cubic centimeter, paraffin 0.80, petrol 0.80, pure water 1.0, mercury 13.6, for gases. In kilograms per cubic meter, air 1.3, hydrogen 0.09, carbon dioxide 2.0. Measuring density, solids. For a regularly shaped solid, like a metal block, first, measure the mass using a balance. Second, measure the volume using a ruler. The formula is volume equals length multiplied by width multiplied by height. Finally, apply the density formula, ρ equals mass divided by volume. For an irregularly shaped solid, like a pebble, first, measure the mass using a balance. Second, measure the volume using the displacement method. Here is method 1. Fill a measuring cylinder with water and note the initial level. Drop the object in and note the new level. The volume of the object is the new level minus the initial level. Measuring density, solids. Here is method 2 for an irregularly shaped solid. Using a displacement can, fill a displacement can to the point of overflow. Drop the object in and water will flow out. Measure the volume of the collected water. This is equal to the object's volume. Finally, apply the density formula, ρ equals mass divided by volume. To find the density of a liquid, first, find the Massachusetts measure the mass of an empty beaker. Add a known volume of the liquid and measure the mass again. Subtract the first measurement from the second to get the liquid's mass. Next, find the volume using a measuring cylinder. Finally, apply the density formula, ρ equals mass divided by volume. Measuring density, air. To find the density of air, first, find the Massachusetts weigh a sealed flask that is full of air. Remove all the air using a vacuum pump. Weigh the flask again. The mass of the air is the first measurement minus the second. Next, find the volume by filling the flask with water and then pouring that water into a measuring cylinder. Finally, apply the density formula, ρ equals mass divided by volume. Floating and sinking, an object sinks if the density of the object is greater than the density of the liquid. An object floats if the density of the object is less than the density of the liquid. For example, glass. with a density of 2.5 grams per cubic centimeter sinks in water, which has a density of 1.0 gram per cubic centimeter. However, glass floats in mercury, which has a density of 13.6 grams per cubic centimeter. Iron sinks in water, but iron ships float because their average density is low, as the hull contains a large volume of air. Example 1. Given. The density of copper is 9 grams per cubic centimeter, and the volume is 5 cubic centimeters. Find the mass. Solution. Mass equals rho multiplied by volume. That is 9 multiplied by 5, which equals 45 grams. Example 2. Given. The mass is 63 grams and the density is 9 grams per cubic centimeter. Find the volume. Solution. Volume equals mass divided by rho. That is 63 divided by 9, which equals 7 cubic centimeters. Example 3. A rectangular steel bar has a mass of 96 grams. Its dimensions are length equals 4 centimeters, width equals 3 centimeters, and height equals 1 centimeter. First, calculate the volume of the bar. Second, calculate the density in grams per cubic centimeter and in kilograms per cubic meter. Solution. Volume equals length multiplied by width multiplied by height. That is 4 times 3 times 1, which equals 12 cubic centimeters. Density equals mass divided by volume. That is 96 divided by 12, which equals 8.0 grams per cubic centimeter. To convert, we know that 1 gram per cubic centimeter equals 1,000 kilograms per cubic meter. So, we multiply 8.0 by 1,000, which equals 8,000 kilograms per cubic meter. Thank you for learning with us.